Okay, so this is a review of what we actually covered last time we met. And what we're doing here is really referring to Zhang, which, as I mentioned, is a good reading to really get an understanding of difference and differences regression. And Zhang, he used this particular notation, right, in this equation that reflects difference and differences. You will be using this equation, not formally in your study, but you'll be using it implicitly in your study, right? So with this, we have the outcome variable of interest, y. We have D2, which is the dummy variable for the post-policy time period. And DT is the dummy variable for the treatment group, in your case, the state, right? And then remember, I refer to this interaction term, DT times D subscript 2, which we're really combining the two dummy variables in this interaction term. That's really the variable of interest for you, right? We'll also have independent control variables that might also influence the outcome that you're going to include. And we'll have the usual error term, things that you can't explain, right? Which is, okay, we can't explain everything all the time. The equation is really a fixed effects regression model, unless you do what? Or you include what?
Random effects?
When we include time invariant variables, then we would have to use a random effects model. Okay.
In time invariant variables such as ag or, okay.
Yes. Mm-hmm.
Repetition, okay, gotcha.
So as I mentioned, this interaction term is really a variable of interest, right? It's the effect of treatment. So it's this term right here, right? dt times d subscript 2, okay? That's your variable of interest. And we can see how all of this is connected. We talked about fixed effects. We talked about interaction terms or variables. It's all connected here, right? And reflected in this equation right here, right? Okay. Everyone understand this? No? Could you?
I was going to say not really, but we're supposed to nod. We're supposed to say yes.
No, you're not supposed to. If you don't, please let me know how I can make it clearer.
It's helpful when I take notes and go back home and reread, so I can do it slower. But right now,
Okay.
I'm not there yet.
Okay. So what we'll do, hopefully, in the next few slides, is move us all along closer to a fuller understanding of this. This you've also seen, right? This is the depiction in a graph of basically what we talked about in the previous slide. So we have an outcome on the vertical axis. We have time on the horizontal axis, right? Pre-treatment and post-treatment. And this outcome here, right, would be for the treatment group, in your case, the state, right, that you're choosing, where this policy is implemented. And we also have a comparison group of states. So remember when I said you really should get or look at all 50 states and decide which states would be most appropriate for the comparison group, right? So we have some outcome that's occurring over time, say enrollment, undergraduate enrollment, and the treatment state implements a policy that would have an impact on enrollment at a particular time, right? So we might expect that it would increase after the treatment, it would actually increase, say, enrollment, right? So it's this line here. So this dashed line is really what we call the counterfactual, right, of enrollment without treatment. So this is not really what's occurring, it's what would have occurred if we didn't have treatment. So it's assumed that it would continue along the same path, right? So the comparison group, we're also assuming it continues along the same path, right? And the difference between the counterfactual, this is the path without treatment, and the path with treatment is what we call the treatment effect, okay? So it's going back here, what we pick up in this variable that's measured by this beta coefficient, okay?
I want to make sure I'm understanding correctly, so I'm gonna like put it in like context from what I was reading. Yes, this is perfect. So what I was reading, it might have been saying, from my understanding, is you're looking at a policy, free college, and we'll use Oregon as an example. And I want to see enrollment change for Black students specifically. I know that it was implemented in fall 2016, so I want to look at 2015, hypothetically, not only Oregon, but I can also look at the regions with the states who are in the PAC, it's called WUE. And then from I should be able to tell from the difference in difference model if enrollment increased specifically in Oregon compared to the other regions that would see if it's statistically significant. Okay. That
Right,
makes sense.
right.
Okay.
Exactly, yes, okay? So this is now in table form, what we just talked about, right? So we have these two groups. And in this case, we're only looking at two groups, right? So we have group 1, the treated, so it's the treated state, and group 2, the comparison group, right? It could be one state or it could be 49 states, right? Or anywhere in between. We have the pre-treatment period and the post-treatment period. And then we have the change, which is really the post minus the pre, which we have right here, right? That's the change. Post minus pre for the treatment group, treatment state. Then we have the comparison group, right, of states. We have the pre and we have the post. So the same thing here, we're looking at the change between the post and what? The pre, right? Then what we're going to do with difference in difference is we're going to take this difference, which is the treatment, right? And this is the delta really stands for the change, right? We're going to take the change in the treatment minus the change in the comparison group, and that gives us the difference in difference. It gives us what we talked about here, right? So everyone clear on that? Okay. So now, here's another depiction by Furquim, Correll, and Hillman, which is, again, part of your reading. So looking at the first difference and the second difference, right? And looking at time, and this, he puts numerical values here, -5, +5, outcome here numerically, excuse me, allows us to really conceptualize what this difference in difference is, right? And again, this is the counterfactual. What is occurring, or what would have occurred, right, here, okay? And the same here. This is actually, the second difference is actually a slight increase.
Oh, okay.
Yeah, okay.
The first difference.
The first difference is, well, this is actual.
Okay.
This would be what it would have been if there was treatment, right?
Oh.
Yeah. Okay, and that's the difference. Okay. So it's really important to take a look at these lines, right? And we'll talk about how you can take a look at it in your own data. But it's important because there's some built-in assumptions of difference and differences regression. There is no selection into treatment bias. So what this is saying is for your state, which has a policy, there's no influencing factors that would have determined that your state had that policy. Okay? So,
Can you use an example?
so the state of Connecticut adopted a policy to provide state financial aid, and this is really Grayson's project, state financial aid to students attending any institution, higher ed institution within the state of Connecticut, right? We're assuming that that policy was, the implementation of that policy was not influenced by any factors,
Okay.
right? There's no bias with regard to the adoption of that policy by Connecticut, right?
Okay.
Or looking at it another way, selection into treatment, right? That's kind of the term that's used in the literature and the stats literature.
And that's like the randomized component. Okay.
Yes, because we're simulating randomized controlled trials,
Right, okay.
okay? And with randomized controlled trials, there's no bias with regard to being selected, okay, into treatment. And this is important. The time trend is the same for both treatment and control groups. So going back here, what we're saying is that before treatment, we had this trend for the treated, and we had this trend for the comparison group, right? After treatment, assuming that the treatment here occurred at this time, we would see a similar trend, right? These are not actually treated, but if they were treated, right, we would see a similar trend. This counterfactual would be the same as this, right?
Irregardless of political context and everything else.
Right,
Okay.
right. So we're assuming that holds, right? There are ways of determining whether or not that's a valid assumption, okay? And we'll talk about that. So together, 1, no selection into treatment bias, and 2, the same trend for both treatment and control groups are called the common trends assumption. So it's assuming that that assumption holds. And as long as it holds, the difference in differences regression estimates the true impact of a policy on programs on outcomes. This should be a true policy, impact of policy or program on outcomes, right? So this is also done for program evaluation. Okay. Now, remember in this example, we had 2 periods, right? You're going beyond 2 periods, right? They'll have 8 to 10 periods that you're looking at. And the additional periods allow us to do these placebo tests, and we'll talk more about that. Okay. So, if we're using a fixed effects regression and difference in differences, and we look at the reading by Furcom and Associates, we have this notation, right? This is post-treatment, this is pre-treatment, or post minus pre, right? For the treatment group and post minus pre for the control group, even though the control group we didn't have treatment, right? where this is the average outcome, T is the treated group, C is the control group, okay? And they represent it in this equation here, okay? Again, you don't have to commit this to memory, but just understand that this is the key beta coefficient. This is the key main independent variable that you're going to be interested in, because you want to see whether or not there was a policy effect, right? And this would give you that using fixed effects regression if you're using that, or random effects regression. Okay. Any questions?
I have two questions. The first one is difference in differences is only for causal, right?
Yes.
And then can we go back to that picture with the lines and like the treatment effect?
This one?
Yeah, so if the line wasn't straight like that, if it was like, then where would you subtract from?
So that's a good question, because in most cases, it's not like this, right? It's usually like nonlinear, right? You would still, and we'll show it when we use actual data, you would still be able to use this to determine, even if you have nonlinear lines. Because remember, with this, we only have, what, 2 periods here, post, pre, and post. We don't have any numbers here. Chances are those lines aren't monotonically increasing, right? They're nonlinear. And we're not really taking into account control variables here either. That's the good thing about equations. They allow us to go beyond 2 dimensions. So with additional variables, we're really saying we're going beyond these Cartesian plane 2-dimensional type conceptualizations of difference and differences, and we're taking into account, and this here I didn't talk about, but we're taking into account control variables, right? Independent variables. So we don't have to worry about that. Okay? But that's a good question.
And the control variables are items like state financial aid allocated for, okay.
Variables that we think might be associated with the outcome. But those aren't the main variables that we're interested in.
Okay, got it.
Right.
Could you go back to the graph from the Furquham piece?
Okay.
Because I don't think I really understood what the first difference and the second difference is.
Mm-hmm.
Because it looks like the same graph
Yeah,
as the
yeah.
other one, but I didn't quite.
Okay, so yeah, it's a different depiction. So first is the comparison group, right? So, and I know the way it's done here is kind of reverse of what I showed in the previous one. So the comparison group is this one here, right? It's the solid line, right? The treated observed is this here, right? This is the treated observed, right? And this is the treated counterfactual. So the treated counterfactual is what? The treated counterfactual is the control as if it was treated. That's the treated counterfactual, right? No, I'm sorry. I forgot that. The treated counterfactual is the treated group as if it was not treated.
Right.
Not
So
treated.
it's like what Oregon would have been
Right.
without having them.
Right, exactly, exactly.
Why is the comparison group, why is there a difference? Like the second difference in the comparison group line? Well, okay, but we're saying, this sort of makes it look like the policy that was implemented caused some sort of change in the comparison group.
Yeah, so let's go back here. right? So the comparison group here, you're saying this is post-treatment, but there really was no treatment, right? So it's post-treatment minus pre-treatment, but there was no treatment. So we have to look at this the same way we look at this, right? And this second difference here is simply, if we go back here, the second difference here is really just looking at this. And if we take this difference, which is the treated, minus that difference, we get the treatment effect.
Okay, I think I'm understanding. So this is basically just looking at like one time period, a single time period.
2 time periods. It's really 2 time periods.
two, yeah. Okay.
So you don't really get the treatment effect the same. It's not depicting the treatment effect explicitly. You have to take the second difference minus the first difference,
So
right?
this is saying that like enrollment happened to increase in the comparison states by a small amount, and it decreased a whole bunch in your treatment state, in the example of the graph.
Decrease?
Yeah,
Because it goes down.
Well, we're going from here to here. That's the comparison group.
Yeah.
And we're going from here, that's the treated group observed, right? Here. Yes, you're right, because this is the hurricane. I just remembered, the example that he's using is the
Yeah, okay.
Katrina hurricane, yes, yes.
Okay, I think I get it. So this is
Yes.
saying in this like, they looked at it 2004 and 2005.
enrollment decrease.
And it,
Right.
we're gonna basically do this for 10 time periods. and
Right.
say, this decrease, okay.
But to get the treatment effect, you have to take the second, or in this case, it would be this minus this,
Right. And we're gonna do that a bunch of times.
Right.
And then see if that is.
on
different.
average.
Yeah, okay.
Because that's another thing. Remember I said that when you get that beta coefficient here, or in this case, it's not beta, it's, what's that, delta? Delta, right? No, you're right. Delta's a triangle. What's this? I'm not too good on my Greek letters. Sigma. Right. Sigma, that's, yeah.
No, that's definitely not a sigma.
It's not.
A sigma looks like backwards 3.
Backwards 3? Okay.
Oh, yeah,
So I don't remember what that is. But that's the notation from Ferquim and Associates. So this is really what you're interested in, right? And it would be,
Sorry.
No, it's not.
it would be
No, yeah, it's a baby delta. Okay.
baby delta?
Baby delta.
Okay. Okay. So it would be the treated minus this, right? First minus second.
I think I was confused, because usually we're assuming that it's an increase, so when it went down, I'm like, what?
Right, I'm just remembering, yes, because the example he used is the hurricane in
Katrina, okay.
in Louisiana, yes, okay. All right, so, you don't have to remember this is just for pedagogical purposes. I used a Monte Carlo simulation, which is, as I explained before, it's when we simulate data and run some statistical technique using a data generating process, DGP, 50 states across 10 years, right? And we assume all the 7 classical assumptions of OLS holding. And we assume that we know the true value of the treatment variable, right? So we know the true value of delta, right? And in this case, I'm saying, I just made this up, 1.75, right? Positive 1.75. So some increases by 1.75. Where the treated state is, and I picked the state in alpha order, so it's Alabama, right? Is it Alabama, number 1 or number 2? Alabama, right? Okay. And there's a post-treatment time in years, and we're looking at 2016 and beyond. We only include one control group in all states other than the state ID being 2, so the 49 states are control. We don't address the implicit assumptions of DID, parallel trends, we don't address, right? So I ran it. Again, this is simulated. This is the value that we're getting. For right now, we're going to ignore the p-value. It's less than 0.0, should be less than 0.05, but we're going to ignore it. Again, this is just to show you something here with regard to using cases, okay? So I ran it again using 1,000 randomly drawn samples, DID fixed effects regression, and ran also some key descriptive statistics, right? So based on this, 1,000, it's 1.75. Again, the more data we use, the better. It's closer to our true value, right? Assuming we have some idea what the true value is, which we don't in most cases, right? That's why we run a model. And we notice that the standard error is much, much lower than what we have here, right? So it means as the standard error gets lower, it means that our estimates are more likely to be statistically significant, right? So again, this is done for pedagogical purposes. You don't have to remember. If you're interested in the code that I use, you can let me know and I'll send it to you. Okay. Now here's a real example from the book, from my book, where I looked at Colorado in 2004, where the state Senate enacted a bill, Bill 189, SB 04-189, to establish the College Opportunity Fund program. So starting in 2005, the year later, the program designated higher education institutions would no longer receive state appropriations. Most of them. I think just a couple in the state were still receiving, like the College of Mines, I think was one of them. Instead of funding provided directly to resident undergraduate students in the form of a stipend to help pay tuition. It's like a voucher, right, that you would get from the state. And you go to the institution of your choice, you present the voucher, and that's it. So the legislation also required that 20% of increased resident tuition by the institutions be set aside for institutional financial aid, right? So this suggested that net tuition revenue would not increase substantially compared to other states. Why? Because they have to what? Provide institutional financial aid, right? If Colorado state and net tuition is what? Tuition minus, gross tuition minus financial aid. So Colorado state policymakers asked whether this policy, COF, had an effect on net tuition revenue. I'm making that up, right? If Colorado state policymakers asked whether this policy had an effect on net tuition revenue, then you, as an analyst, would probably use a fixed effects regression, DID model, to answer this question, right? That's how you would get at this, okay? Here's another example from the higher education literature by Hillman, and Hillman has done a lot of studies, policy analysis using DID regression. This is a good one. where they look at, again, Colorado and the voucher model that we just talked about, whether or not higher education access and efficiency increased, right? Or what did it do? What was the impact on access and efficiency, which they define in several ways? So they're actually looking at multiple treatment outcomes. And you can do that, but we don't have time in this class to do it, right? You could have, your outcome could have been one of several, right? If you wanted to look at a policy effect on an outcome. I would argue going forward, that's something that more analysts should do, because some policies may have what we call unintended consequences. So we're not only looking at what is the goal of the policy, but we're also looking at how that policy may have affected things that were not the goals of the policy, right? What we call unintended consequences with regard to a policy. And I think more needs to be done. I provided the link in the slide so you can actually go to the article and look at it, right? Why don't we do that right now? Why don't we, just a quick look at this, if we can.
Oh, it's no paywall.
I'm sorry?
There's no paywall.
Right. If you go through Google Scholar, I know that there's no paywall.
You know Dr. Titus got the juice anyway.
So if we go, I always like the PDF version of this. I hope I don't have to download it. I may have to, yeah, I downloaded it. Okay. I don't want to go to my download drive. But if you go to the table, let's see, table, full-size table. Okay, here's table 3, I think. Yeah. So if you go to that table, you will see, as I mentioned, efficiency is defined in several different ways. So they look at costs per FTE, they look at costs per completion, right? So that's cost per degrees completed. And they look at completions per FTE, 100 FTE. So those are measures of efficiency. Then they look at access, low income enrollment, logged, right? Because it's probably not normally distributed, right? And then they look at African American enrollment and Hispanic enrollment, right? As additional measures of access. And then they look at this in comparison groups. Neighbor, right? And they define what the neighboring states are. WICHE, Colorado is a member of WICHE, so they look at, and TABOR, which is a policy that some states adopted with regard to spending. So they look at those states. Colorado was among those states, so they looked at other states that adopted a policy with regard to their overall state budget, right, or expenditures. And they included these different groups, right? And these are institutions, so that's why you see the observations being so high. In terms of institutions, observations in terms of institutions and states. So they looked at groups of institutions within the different states of comparison, and they included institution fixed effects, right? So that's what? Say things like culture across institutions that don't change, that's not measured. Year fixed effects, remember we talked about year fixed effects, so that's capturing the effects of a policy that's applied to all states equally, right? They included the R-square of these different models, and they included the the effects of the policy on these different things, right? Okay. So, actually up here, they included each of these. So efficiency and access with these different measures they looked at didn't seem to have an effect on efficiency as measured by costs per FTE when going beyond neighbors, so going to WICHE and going to TABOR states as control states. Cost per completion, neighbor compared to neighbor, dropped, right? The effect on costs, we had negative effect, so cost dropped. But then looking at low income enrollment, no change. There was no effect of the policy on low income enrollment. African American enrollment actually dropped when looking at the WICHE compared to WICHE states, right? Anything you see with the stars, the asterisks, right? Statistically significant. Hispanic enrollment also dropped as a result of this policy. Neighbor states compared to neighbor states, compared to WICHE states, compared to TABOR states and non-TABOR states. You had a question?
Yes, so if there's, so in addition to if it's an asterisk, I can never say statistically significant, but also if there is a negative, that lets you know decrease, and if there's no negative, increase.
Right,
Okay,
right.
just wanna make sure.
So one could look at this and say there may be some differences in terms of the treatment effects for different groups of students, right? All of you will be looking at one outcome, so you're not looking across these different outcomes, right? But what we're looking at here, when we look at the efficiency measures and the access measures, we're looking at outcomes, the effect of the policy on an outcome. So each of these, they're really that interaction term, right? Each of these reflects an interaction term, right? So everyone clear on that? So I would really take a look at that article, okay?
Especially for those doing different and different.
Right, exactly.
So you all are doing a causational review? Okay.
Mhm.
All right.
Because we're looking at a specific policy, which is the Promise program in Oregon. Thank you so much. And then what was that like impact on, for me, Black student enrollment in particular?
So if Younger and Satra published together, it would be similar to what we just looked at, because you would have looked at two different outcomes using the same model, right? So it's not like, you're using one set of independent variables and both of you would have to use the same set of independent variables, but looking at different outcomes. So you have to run two differences in differences regression equations.
And GIE regression is particularly used for causational analysis.
Right, exactly, right.
Which one's for correlation?
Correlation is what Macy and Bailey are using. So they're looking at the relationship between some variable of interest. So Macy's looking at
Undergraduate student enrollment and need-based scholarship.
need-based scholarship, controlling for other variables. And Bailey is looking at
First-time, full-time undergraduate Black students at public four-year institutions, so
Better
that
speak
their
on that.
enrollment.
Mm-hmm.
Oh, okay.
And the independent variable is affirmative action ban,
Right.
state affirmative action ban.
Controlling for other variables. Yes.
And other things. And other things. Okay.
But those other things are not your main interests, right?
Right.
So in the past, some students found like no relationship between their dependent variable and their main policy relevant independent variable and said there's no relationship, but there are all these other things that are related. That's okay, but that's not
So would we?
our main interest.
Things and-
You would mention that,
But you don't identify them as a independent, an independent variable.
they're still independent variables that are related to your outcome. But that wasn't your main interests and your focus.
So you would say there are other independent variables that could,
Be related, or that are, if you found them to be statistically significant,
okay,
to your dependent variable. You could talk about them, but don't spend a whole lot of time on them, because that's not really your main interest or main
we
focus.
need to talk about this today.
How do you know whether to do correlational versus causation?
Well, it depends on your resource question.
Oh.
So if your resource question is, how does this relate to this, that's correlational. If your research question is, how does this impact this, right? Yes. In the literature, before differences in differences regression was used, there was a lot of confusion with regard to the language. Some people were using correlational, and they found a statistically significant main independent policy-related variable
Yes.
to their output or dependent variable. And in the write-up, they would say, that variable impacted or influenced that.
Yes.
That was not the correct language to use. The language should have been associated with or related to, not impact, not affected, not influenced. Wrong language. Yeah.
Policy folks do that a lot.
Yes.
I was like, what's the difference?
Yes.
Oh.
Yes,
okay.
yes.
Thank you.
They're going one step further, right? They're with the language that they should not have,
Yeah.
because it didn't match with the research design, with the technique that was used.
Okay.
Yeah,
So the technique is very important in whatever conclusions you made. Okay.
yes. The technique, language is important, right? And your research question, right? So all of those things should be consistent, right? Your research question should be consistent with your technique. And your technique should be consistent with your language that you use when you talk about the results, okay? Okay, any other questions? Okay, so remember I mentioned that we really should get a sense of, if we're doing causal inference, right? Difference and differences, we really should get some sense of the data. So I'm using the same example of net tuition revenue per FTE student in Colorado, right? And in this case, Colorado is the dashed line here, and the other states here, okay? Dollars on the vertical, fiscal year on the horizontal axis. It was implemented in 2004, but really, after that, is really when we would look to see what the effect of the policy is. So remember we said parallel trends is supposed to be a implicit assumption of DID? Well, what we do is we look at these trends prior to the implementation of the policy. And this we can do. I have the syntax for this, the code. You can actually set this up with your own data, right? To look at these trends. But again, you need to have data on the other states, right, that are appropriate to compare to. So you look at the treatment state, Colorado, and you look at the other states. It looks fairly parallel to me, right? Doesn't have to be perfect. And then you look here, well, there's a jump here, right? And then there's a decrease, a jump, a decrease. It tends to widen. Doesn't tend to be parallel over time, okay? But this is fairly subjective, we have to say, right? It's all in the eyes of the beholder, right? Okay. And then we use another comparison group. Say we compare to the WICHE states, right? These are the same states in the same academic compact, right? It looks parallel, fairly parallel before the policy. Kind of parallel after the policy, right? Implementation, okay. So again, this is subjective. And we'll talk about how we can do it or look at that more objectively, right? So before that now, what we're going to do is set up the DID, in this case for Colorado, which is the treatment state. So in Stata, we would simply type in T, if that's what you're going to use to designate the treatment state. T is equal to 0, and then replace T is equal to 1. If state, you could use state FIPS, I just use state abbreviation here, is equal to, double equal to CO, bless you, in quotes, right? If you put in state FIPS, you don't have to put in quotes, just put in state FIPS. Then the post-treatment period, generate P is equal to 0, replace P is equal to 1 if year is more than 2004, because we want to see what, after the implementation of the policy in 2004, what is the effect? So we say if year is more than 2004. That's the code that we would use. Then we want to set up the outcome, Y, net tuition revenue per FTE. We have some variable in there, net to it FTE, right? So we don't have to create the variable, that's just our outcome variable. But we also want to have control variables that vary with time. So state appropriations, we have a variable in there already. State per capita income, we have a variable in there already. And we want to save steps here. So we just put in the global control is state appropriations per FTE and per capita income per FTE in quotes, right? So we just call that controls. Okay. We want to have our comparison groups. So we start out with all other states, 49, so we're going to call that C1. That's the first one. C1 equals 0, replace C1 if state abbreviation is not equal to. And this is the code that we would use, again in Stata, not equal to state abbreviation CO. Then we set up one control group only including WICHE states, not including Colorado. So we have some codes in there. We have the WICHE codes in there. And again, if you plan to do that, I can show you how to do it. Not equal to Colorado, but within the regional compact where it's equal to 2, which is the code for the WICHE states. Border states, this is a little bit more involved. You have to, for me, I had to look at a map when I did this, right? So that's the third control group. Wyoming, Nebraska, I believe, Oklahoma. I didn't realize Colorado bordered Oklahoma until I did this. It's like, it's further south than I thought. New Mexico, Utah, Arizona, right? And regional compact equal to, right? And then I simply put in, well, I had already put this in, I redid that. And then the global Y is equal to net tuition FTE. That's my outcome variable, right? And I run it like that because I didn't want to type everything in again, right? So I run it like this where $Y, and then I use the double hash marks to do what? To get the interaction term, right? Controls, because I don't want to type everything in again, right? And then I only want to do it for the first control group, where treatment, this is the first control group, or treatment is equal to 1, which is Colorado, right? I run a fixed effects, and I take into account robust standard errors, right? This is what we would get. So this is for the first control group. This is the treatment effect, right? That interaction variable, and how do we interpret that? This is in dollars. So it's actually saying compared to the other 49 states, there's actually an increase in net tuition revenue, okay, compared to other states. There was an increase. It's not really doing what it's supposed to do, right? If there's an increase over and above what other states are getting, and we're controlling for state appropriations and per capita income. I also included year fixed effects, but I couldn't show it here because I would run out of space. So I just, when I did a copy and paste, I just took the year fixed effects out, right?
Why doesn't this one have an asterisk next to, to show that it's statistically significant?
Because it doesn't in Stata. What you would have to do is go here to where the p-values are, and then you could see what the p-value is. I think it's, yes, 0.000, so that's less, p is less than 0.001, is what you would write in your paper, right?
Okay.
If you were doing this. You wouldn't have to show the year fixed effects either. You could just say year fixed effects in your table and yes, right? Okay, so now the second group, right? I run the same model again. All I have to do is change this to C2 is equal to 1. That's the second control group. What's the WICHE, right? That's the WICHE group. So, wow, it's even higher than the WICHE group, right? Net tuition revenue, right? After the implementation of the policy, right? It's statistically significant because I believe that's 0.001, yeah. Okay. Okay. Notice the number of observations actually decreased from 850, right? Because we had number of groups 50 to now number of groups 13, right? Because we're only comparing against the WICHE, okay? And then I run it again for the third control group, which is the border states, right? Same thing, I just changed this, right? It's substantially higher than the border states, right? It's statistically significant. P is equal to 0.0, P is less than 0.05, right? This is significant, but we're really not going to dwell on that. And you would expect that, right? The more state appropriations, the less net tuition revenue, right? I could write a paper based on this. I could, as my former professor used to say, I could wrap a lot of words around these numbers, right? Okay, but notice something here. Your number of observations are down to 85. I start to get a little nervous when the number of observations start to drop, right? I still have a lot of years here, 17 years, but the number of observations, they really dropped a bit. And remember when I did that simulation, when I moved from a small number to a larger number, we get closer to the true value. So going the other way, it's getting away from the true value, right? The lower we go in terms of the number of observations, okay? Okay, so any questions about this? For those of you who are doing causal inference analysis, any questions? Well, I can think of a couple. So how is it important to really identify your comparison states?
You said how?
How important is it? Yes,
Very.
Yeah.
very.
It allows you to see if there's a difference in the trends. And it's a good, just a comparison group to see if there is an impact.
Mm-hmm. Mm-hmm. Yeah, it's important, yes. Mhm.
I was, so when you say comparison groups, could you also say control groups, or is that like not?
Yeah, you can say control groups. I tend to use them interchangeably, but if you want to be more specific, you're really comparing the treatment to an untreated group of states, right? So that's the one thing. So comparison is probably the more appropriate term to use, but I'm not saying that, that's what you use. It's up to you. And then the word control, I would probably use for the variables, your control variables, right? So you have these control variables, and then you have these comparison groups or states, two different things. But I would just be consistent with regard to whether or not you plan to use control or comparison. Those of you who are doing correlational, you don't have to worry about comparison groups, right? You're using controls.
For thinking about, I mean, this is obviously specific to my project, but
Mhm.
Oregon only has 4 border states and there's only data for 3 of them. So, I mean, my instinct is to say that's too few to really be a good comparison group.
That's also my instinct.
Okay, yeah. So you can disregard that part of my.
Yeah, unless you have a long time period, right?
Yeah.
So, yeah, that's my instinct as well. You probably would not want to use the border states as a comparison group. Some analysts go through an elaborate procedure to get to a appropriate comparison groups. I think Grayson asked me something about using propensity score matching, which you're trying to match a similar group to the treatment group. We don't have the time to do that in this class, and it would require learning another technique, because the matching involves the use of another regression type technique, right? And we don't have time, and many people don't use it, right? What do you see as some challenges with regard to having a study where you're actually producing estimates of treatment effects for different comparison groups? What do you see as a challenge with that? And think about the paper, that example that I provided.
Colorado?
I'm sorry?
The Colorado?
Yeah. Not the one in the text in my book, but the one from Hillman Associates,
Oh,
where they had different comparison groups. So they had Ritchie, they had Tabor states. I think they also had border states. I can't remember. So what are some of the challenges with regard to doing that?
Well, because you're really trying to, I mean, for lack of better words, you're guessing, right? You are assuming that, I've already forgotten what their main thing was, but that it's going to stay on kind of the same trajectory that it was before. So we're talking about enrollment, right? That like enrollment would continue to do this, and then you're looking at something, right? So like that's not always the case.
Right.
And especially when you're comparing that to actual data from other states.
Yes, that's true. And also, you're getting different results based on the comparison group. So for one group, there may be a treatment effect when you compare the treated state to that group. But then when you have another comparison group, there's no treatment effect. So what can you conclude? You have to report what you get. You have to report it and say what you get. This is what we found. There's a treatment effect when we compare it to one group, but there's no treatment effect when we compare it to another group. You just have to report that. That's a challenge now for policymakers, because they have to decide, well, is this thing working or is it not working, right?
And in those instances, so this is what I was thinking too. I feel like even with whatever the outcome is or whatever you find out, you still need to do some like case study or case making for why there is. So I'm, in the instance about enrollment, for example, in comparing two states, I'm even thinking about COVID, like there were just different initiatives in different regions or different states supported higher education differently that may not be accounted for when you're looking at the trends over time. And so if in the example you use, if in one treatment group there was nothing, but then you look at another, would you want to do something?
You mean comparison group?
The comparison group, sorry.
Right.
So the comparison groups, one there was, how did you frame it again?
So there may be treatment effects when you look at the treatment state compared to one comparison group,
Right. Like
and no treatment effects when you compare it to another comparison group. Yeah.
Okay. And so would you want to, I think as a researcher, I would want to find out why was it in one control group than the other?
Yes, you would want to, but statisticians always have an answer. So remember we just looked at the bordering states where there are only 85 cases?
Yes.
And remember we talked previously about a simulation effect, or a simulation when we looked at 1,000 cases, getting closer to the true treatment effect? Well, as a statistician, you put on your statistician hat now and you say, well, we're probably going to look at or have more confidence in when we have more observations, right? So if having a control or a comparison group that's larger, which 49 states, chances are that's closer to the true treatment effect. Right? Because I ran a simulation and I proved that would be the case. That's your statistician hat that you put on to answer that question. Okay. Any other questions? One of the things I like about teaching this class is every year I have you pose questions to me that I wasn't able to answer in the previous year, right? Because I didn't run a simulation like I ran this year, right? So that's great. It gives me an opportunity to also educate myself with regard to some of the things that we could answer, or some of the answers we could provide to people when they ask questions.
Could you ever be like, wow, I only have 85 cases, so I'm just gonna take those 85 cases and replicate them a bunch of times to create a big data set of the same?
You don't really do it that way.
So I was like, what if I had made 70 Californias and 70 Idahos and said, compare to that?
Well, there are other ways that you can do that, but not that way, right?
Okay.
So I had a student who took this course, and he was a math major, and he said, I think there may be another way of getting at this, and he decided to, and this actually educated me, he decided to use what's called a synthetic control method, where you look at, say, Oregon, and you say, well, what are some states like Oregon? based on a number of different factors. You run it through this technique. I've never used it. He learned it. He convinced me, based on the literature that he presented in his dissertation proposal, that this is something that is up and coming in the field and people are using it. He ran it. It was a different topic, right? Looking at responsibility-centered management and budgeting and the effect on expenditures at the institutional level for 2 institutions. So we had to, what I call, do a Frankenstein creation of these 2 institutions, right? That you can compare each of them to, right? Using a whole lot of data over time. So that's one way of getting at the effect of a policy if you're limited in, the states bordering you. You could kind of recreate these pseudo-states, right, that have some similarity to California or Oregon or whatever state you're looking at, to answer a question.
So you're telling me I can't just make stuff up?
No, no, but you can statistically make stuff up. Yeah, because as I said, these comparison states it's like, I use the analogy, and it's probably appropriate as we approach Halloween, but it's like you're creating a number of Frankenstein states that you're comparing to your actual state. Yeah. But it's called synthetic control modeling. And he did it, and he did his dissertation based on that, so yeah. And I learned something. Okay, any other questions? I want to continue because there's some things that are related to what we just talked about, difference in differences regression. So in order to determine whether there is real evidence of the effect of a policy on, or some unknown factor, placebo tests are required, right? So there may be some things that are affecting an outcome that have very little to do with the policy, these unknown factors, right? And these tests involve estimating the treatment effect after changing the treatment timing. So if our treatment occurred in, say, 2018, we could move it back, statistically speaking, to 2016 or 15 and see whether that effect occurred, okay? And we'll demonstrate that in the next slide as we change the timing in our example to 2000 and simulate the treatment to occur before the actual treatment occurred. And that's why I encourage you to have as many years as possible so you can do these placebo tests, okay? So we choose a random post-treatment year or years, 2002 and 2003, which the prior to the treatment year when Colorado actually enacted the Senate Bill 189, and we use these data code to do that. So we generate placebo underscore 2002 is equal to 0. We place placebo 2002 is equal to 1 if year is more than 2002. So we're moving the policy effect back, right? And we create another one for 2003, okay? So we're saying, what if the policy actually occurred prior to when it actually occurred? Okay? That's what we're doing. So we use the same variables and comparison or control group, whatever you want to call it, states. Say for the 49 states, we run the placebo test for the 2002 enactment, right? And we see basically what? We're looking at that interaction term in bold. What do we see here?
Statistically significant.
Right. There's an effect on net tuition revenue. Yes, compared to the 49 states, right? Okay. Then we run it for 2002. We push it back even further, right? What do we see? There's an effect. So obviously this policy may not have the impact that we thought it had, because if we move the policy, the timing of the policy backwards, run this placebo test, what we're saying is we see the same effect.
Would this be like omitted variable bias or something where like there's something we're not including in the model that it's not capturing the variance
Yeah.
properly? Yeah.
Or it could be this.
This just got water.
It could be this, what we call anticipation of the policy before the policy was implemented. So some institutions start ramping up their tuition because they say, oh, those folks at the state level, in the legislature, they're having these discussions. Policies usually, they don't just
That's true.
instantly come about. They have policy discussions, debate, et cetera, years prior. And institutional leaders are very sophisticated with regard to policies. And they start looking ahead and they say, we should start increasing our tuition now because we're going to get no funding from the state after 2005. So why don't we start increasing our tuition now and start banking it, putting it aside, right? That might have been occurring, but we don't know. That's where the qualitative people come in. They would do the interviews. Oh, so what were you thinking before this policy? Was there any planning taking place, discussion, measures being implemented? I would say that's where the qualitative people might have to come in.
So if you get this in the placebo, you probably, but what do we do from here? Like if we're like, okay, well, we did the placebo, so maybe it's not our variable,
Right,
our treatment.
Is that
Right.
paper?
right,
Is it?
yes. Maybe there was no policy effect here. And it could be in anticipation of a policy that you got this outcome.
I feel
Okay.
like in the real world, right, you would do these tests and be like, oh, nothing here, I'm not gonna write this paper, right? Like,
No, you write it, you still write it.
but is it gonna get published anywhere?
Yes. Because some people might say, you see what I'm saying? This policy had no effect. Why did you implement it? There were other things that were going on.
Here's my proof.
Yes, here's my proof.
It feels so much harder to be like, I did this placebo test and I proved there was no impact versus, like, how do you, I don't know.
You may
That-
be able to publish in like a non-scholarly journal, like a policy, like a Brookings or something.
Yeah, or a scholarly journal. There are scholarly journals that would accept something like this. Because, you might get a lot of questions and pushback from referees or reviewers, but yes, remember, and this is the broad approach to doing what I call scientific quote-unquote research. The goal is not to prove something right. It's actually to prove something wrong. But in higher ed, I guess we're so wedded to policies and programs, we want to prove it right. But in the scientific world, it's actually to prove a theory wrong. And then you come up with something new. Right? That's what is done in the scientific world. Okay?
So this is what happens when you like use different disciplines, methodologies and try to fit it in like a psychology methodology in an educational. Okay.
Or I would say, in higher ed, what we end up doing is kind of turning the research world on its head.
Yes.
Because the research world, as I said, it's about proving a theory wrong. It's not about proving it right. Because that's not the way the science advances. You don't advance in science by just proving something right. You advance in knowledge and science by proving something wrong and then moving on to a new theory that would further explain something. There's an interesting, and I know I'm going off tangent here, but I have a layman's interest in astrophysics, right? I don't understand like the details, the mathematical details of it and the scientific details of it, but I just have this general interest in astrophysics. And one of the things that is kind of turning, is posing all these questions to astrophysicists and cosmologists, is the data coming back from that satellite, it's a telescope, space telescope, James Webb Space Telescope that they sent up a couple of years ago, and it's coming back with all this data. One of the things that is challenging scientists is they're thinking about the creation of the universe. The long-standing theory is the Big Bang theory, right? Something happened the size of my fist in a vacuum someplace, and it exploded and it created our universe. And they estimated, based on additional data, that the universe is about 13.6, give or take a million, billion years old, right? This telescope is discovering galaxies that, based on additional data, that's like 26 billion years old. So that's saying something's wrong here with regard to this Big Bang theory, right? Because according to that theory, it's 13.8 billion years, not 26 billion years. So maybe something's wrong with that theory, and we have to rethink that theory. So it's a very exciting and to some frightening thing they're discovering. But that's kind of what science is about. It's disproving, it's getting data to disprove a theory, not to prove a theory. So this is sort of like that, right? And for some of us, it might be disappointing when we find these results, because in many cases we're so wedded to a particular theory, program, policy. We want it to work so badly, but we can't dispute the evidence, right? We have to report what we find. Okay? So this is an example. Okay? So you will have to do these placebo tests, right? There's another stated command. It's called XTDID regress that you can actually run, and I encourage you to run. You would, and I have an example here, you would use data that's available. You'd set it up similar to what I set up, but with slight difference. You would create a treatment state and treatment time, right? You would combine. You would use the same variables, okay? And you would run it to get results. You would also take into account what we call intergroup correlation. So some states, what's happening in one state may be correlated to what's happening in another state. This particular procedure takes that into account. And this is how you would actually run it. And this is what you would get. That's the first part of it, utilizing 49 states as a control group. Okay. You would get basically the same results using this procedure as we did when we ran it using XTReg FE-RAB. It's the same result. So that's a way of checking to see whether it would be consistent with what you did using the same control variables, and including fixed effects, year fixed effects, which I omitted here. But in addition to that, you could also get graphs, right? So we could enter what we call post-estimation commands to get graphs. So in the first panel, we see the observed means for the years that we're looking at. And we're looking at net tuition revenue per FTE for both the control and treatment. The control is in blue, the treatment is in red. And then we could look at linear trends, right? So it's similar to the observed, but this is estimated, right? We see it similar. So from this, we can also determine whether or not we have the parallel assumptions, right? Parallel trends assumptions, right? And we could go a bit further and test whether or not we have parallel trends assumptions. So we can indicate, based on this test, that the parallel trends assumption holds. Because the null is that the linear trends are parallel. That's the null. If we don't reject the null, then we can say that they hold, right? So this gets at the question that Barry also was asking, what if those lines are nonlinear? Well, now we can test, even if they are. Okay. We can also perform what is called a Granger test. So remember I said the anticipation of treatment? When we use the placebo, we can carry out another test. It's like you're a doctor. You're like a medical doctor, and someone comes to you and says, I have this condition. And the doctor says, well, I can run one test, and I can run another test to find out whether or not you have that condition. So you can do that, right? First, you run this test, then you run this test, and you see the null is no effect in anticipation of treatment. What if you reject the null? The anticipation of treatment. So it's consistent with the placebo test that you ran. So if someone came to you and said, well, how do you know that there's no treatment effect? Well, you could say, well, I ran a placebo test, and I ran a Granger test. And they would say, what is that? And then you tell them. Okay. This isn't something that's done in the literature. I haven't found anywhere in the higher education literature, in the other policy journals, yes, but in the higher ed literature, I haven't found this. I get a feeling that many people don't know even these tests exist in the higher ed world, okay? Because these tests were developed by economists, or this particular test. So it probably wasn't reported in the higher ed literature, right? In the econ literature, econometrics literature, in the policy literature, yes, but not in the higher ed literature, okay? Okay.
I want to make sure I understand what you just said, because I'm saying in my head. So it is significant, because it's less than 0.05. And so because it's significant, it's showing that there was a treatment, there was something.
Yes, it's rejecting this, that there was no effect in anticipation of treatment.
Okay.
There probably was some anticipation of the treatment that affected the outcome.
Okay.
Yeah. So you would run this. Okay. Okay. So, in addition to difference in differences, there's also something called triple difference in differences, DDD. Okay. So this concept, using the notation, and this is a really good explanation by this particular person. If you click it, you go to the video, right? Where there's an outcome, there's a treated state where the policy is implemented, there's a specific group that is targeted by the policy, then there's a group that's not targeted by the policy. Then there are comparison states where the policy isn't implemented, and there's a post-treatment period and a pre-treatment period, just like regular D&D. This is the equation that you would set up based on that, 1 through 6. And what does this mean? This is the one that you really have to be concerned about, the delta subscript 3, where you have an interaction term for 3 different things here, right? So this interaction term really reflects all of this. So this is the difference between post-treatment and pre-treatment for the group that is targeted for treatment in the treatment state. The second one is the difference between post-treatment and pre-treatment for the group that is not targeted in the treatment state. And then the last one is the difference between post-treatment and pre-treatment for the group in the control states. So you can turn that into a regression equation and you can run it, and you would focus on delta subscript 3 to see what the treatment effect is. I encourage you to go to the video, right? A good explanation of that. This is not used a lot, but I did find in a non-higher ed journal that it was used estimating the impact of COVID-19, actually, pandemic on educational outcomes for undergraduate business programs in Mexico. And then there was another one in policy research, or research policy. Higher education policy, why hope for quality when rewarding quantity? So if you're interested, you could take a look at it. We're not going to cover triple differences in this course. Okay. But that's another area that's ripe for more discussion in our literature, usage in our literature. Folks who are interested in it, you want to make a name for yourself utilizing this. You want to do a dissertation. There's no one that I know of. I think maybe 1 or 2 people. But that's another area. Zhang briefly talks about it in a page and a half, 330 to 331. His notation is a little, in my opinion, not clear, right? So that's why I included the previous slide with the link to the video, right?
So you could use this to look at like a policy targeting community colleges, right? To look at like outcomes for community colleges versus four-year institutions across many states.
Right.
That seems like a pretty easy thing to use in higher ed.
Yes. Or you can use it to look at community colleges, and your unit of analysis would be community colleges, and you look at that in addition to where that policy is not occurring in other states. So you're taking into account state as well as institutional fixed effects. Yeah. With the provision that you're also looking at four-year institutions, right? Comparing four-year institutions, okay, in other states. Okay, so why don't we take a break? And you can look at the limitations. I really encourage you, if you're using DID regression, to look at the limitations, because that's basically what you're going to be saying in the limitations part of your paper. So I'm not going to go over all of that, but why don't we take a break? I couldn't resist that. All right. Okay, so why don't we come back at about 6:15. That's approximately 10, 11 minutes. And we'll do some hands-on work.